My name is David Leichner. I'm the CMO at SQream. And with me today is Ayelet Heyman, who's our VP of product. So you have in the room a couple of very interesting people from SQream. Quick question for you. How many people in the room have more than 50 terabytes of data in their organization? Okay. Okay. So you should meet with Hanan Cohen, who's sitting in the back row there. He's actually the person responsible for business in Europe. So we would like to have a conversation with you once you've seen this amazing product. Great. So I'm going to start off with basically just going through setting the stage, you could say, for the technical part of this presentation by talking about the challenges that companies are facing with massive data analytics. So I'm going to jump right in. This slide basically shows you that CPU-based technology, x86 technology, has stayed relatively stagnant over the years. And we can see that GPU technology, as we know, and as NVIDIA has made a lot of noise about, has obviously grown substantially. The technology, the capabilities, performance capabilities, and so on. Now, what you're seeing here is data that's grown, and as we know, there are different analyst companies that are talking about the fact that 90% of the world's data was created in the last 2 years. Every month, we're going up by X amount of data in the world, terabytes, petabytes, up to trillions of whatever that we're going to have in the world in the next 2 to 3 years. So organizations are facing major hassles in both storing the data and getting information off of the data. And one of the reasons is because the data warehouses that they're using were not built to handle this kind of data. Back when I started out 30 years ago, we were talking about megabytes of data, and we went to gigabytes of data. Well, today, we have companies that we're talking to who are trying to tackle how to analyze the data coming off of hundreds of petabytes of data. So the visionaries at SQream, when we started out, they were looking at how to handle, let's say, hundreds of terabytes, looking into the future and understanding that there's going to be this tremendous growth. And part of the growth, and the reason for the growth is, as I mentioned, the x86 systems are not advancing the same way that we're seeing, for example, GPUs advancing. So if you look at a typical query, this was actually one of our customers. They were getting data off of micro antennas, and it was taking them 30 minutes to transfer that data into the data lake. It was then taking them 3 to 5 hours to ingest the data, to create the cubes, to aggregate the data, basically the data preparation level, taking 3 to 5 hours, and then going from the legacy MPP, it was taking them another couple of hours to get the query out. So we're talking about up to 9–10 hours to get one query done coming off of those microcells. Okay, so this is the challenge, is that these SQL queries are taking way too long, and business intelligence is limited by the amount of data that you're actually able to query and to analyze. So estimates are that 90% of business intelligence is being lost in organizations. And when I talk to companies at events or at business meetings, so what they're telling me is that they're analyzing 10 to 15% of their data. They don't even know how much data they have. And if we're talking to the data scientists, they say, talk to the database person. The database person says, yeah, we have hundreds of terabytes of data. We can only offer up to 5 terabytes of data to the data scientists in order to do the analysis work. And so at the end of the day, the reports that are going up to the C-level, to the board, it could only have 10, 15% of the data actually analyzed. They might not even know that. They might be getting their reports saying, well, this is great information. But then they come back and they check and they say, well, why am I only getting historical information of a week? Why can't I get a year? Why can't I get 2 years? So these are the types of challenges that we're tackling. So basically, you could say this is our elevator pitch before I hand over to Ayelet. We can analyze 20 times more data. We can do it 100 times faster at 10% of cost. And this has been proven in use cases that we'll talk, if we have time, we'll talk about it later on today. Just one more slide showing what we are before we hand over, and Ayelet will go through how we did it. So we are a data warehouse powered by GPUs, massively scalable, so we can handle everything from a terabyte of data up to petabytes of data. We are an SQL database, really important. We realize that most of the data that's being, where the struggle is in order to analyze that data is coming off of corporate data, enterprise data, which today different estimates have it at 75–80% of that data is SQL based. So it was really important for us to have this data warehouse be standard SQL, extensible for machine learning and artificial intelligence, very minimal footprint, and we'll talk about that later on, and very, very rapid ingest of data. So one of our goals was to go from the point of bringing data into the system to point of getting it out. So time to query, time of query would be extremely, extremely fast. And just yesterday, we announced that we are now available for Power 9. So it was very much in line with this event. So we made this announcement yesterday that the data warehouse SQream DB, we boast query performance of up to 150%, and Ayelet will drill down into that. And you can see here a quote from one of your colleagues for the IBMers in the room. This came from Sumit Gupta, who is the VP of HPC. And he wrote basically that the combination of SQream and IBM Power 9 platform takes this concept to another level of performance. So with that, I'd like to hand over to Ayelet, who's going to go through and get more into the technical details.
Thank you, David. I feel like a rock star talking about GPUs. Okay, so as weird as it may sound, you hear me well? We developed a database from scratch. And this is not something that is very typical to business personnel who wants to go fast to the market. Why we did that? We did that in order to fulfill our mission to provide high-performance data analytics at scale. As David said, we are not in the business of 1 tera, 2 tera, 5 teras. We are in the 500 tera and going north. The way to do that was to combine our advanced technology together with the parallel processing of the GPU. The main 3 operations we need to manage was loading data to the GPU, executing the data, and then extract it back. NVIDIA technology enabled us to do this very efficiently in a high-performance manner. What we did, we used the pin memory to transfer the data to the GPU. Having the asynchronous copies of the data together from and to CPU, GPU, together with NVIDIA streaming programming model. We got into concurrent CUDA operations, and this enabled us to utilize the GPU into a maximum. However, we were still bounded by the PCI, which introduced the typical I/O bottlenecks. So IBM called it NVLink, we call it the missing link. What NVLink enabled us is to take the concurrent CUDA operation into a new scale by enjoying the full bandwidth of the NVLink and then reducing the I/O bottlenecks to a minimum. Now, it's not just the cores or the NVLinks. We are looking at it as a whole system, a whole ecosystem that for high-performance computing. Where I am? Okay, this is the interesting part. Let's take a look at the results. We did a benchmark with the TPCH. We are comparing the IBM Power 9 to Dell PowerEdge. As we can see, loading time on the Power 9 is nearly twice as fast from the x86. So I think everybody can understand why we are going on a partnership with IBM. Query time also depends on the query, and later on we'll see why. But we got, again, and this is again comparing to the Dell PowerEdge, we got between 150% to 370% faster of the query execution. And this, the query time is mainly enabled due to the NVLink bandwidth in order to apply the complex join operation, group by, and so on. So how we do it? A few words about the process chain in SQream. We have the raw data. We are a columnar-based database. We are doing chunking. In a minute, we'll go into each block in details. We are doing chunking of the data. Chunking is a new term that we are using, which split the data and then gather the data back in an optimized manner so we could process it fast. Another nice patent we have is the automatic adaptive compression. Since we are a columnar database, we are able to optimize the compression to the data. And we are automatic choosing the right compression that enables us fast query time based on the data. Then we are doing the data skipping. The metadata tagging allows us actually the data skipping. This is, let's say, a replacement for the indexing that most traditional databases are having. So we don't need to do the indexing. We don't need to know in advance what the query we are going to read. Now that we have these small chunks that are only the relevant chunks that we would like to query, we are pushing them into the GPU to apply the parallel processing. So columnar data, columnar database, we have row-based, which is Postgres and all the rest. Columnar is good for analytics, for aggregation. It allows good compression of the data. Actually, it allows more efficient compression of the data. The chunking operation. This is done behind the scenes. So we are partitioning the data into multiple dimensions, both on the size of the bulk of the data, as well as the content of the data. All of this is being done behind the scene during ingest time. Now remember, guys, we don't have any indexing on the data. So now we are tagging the data while we are loading it. For each chunk, we know distribution of the data, we know all kinds of metadata statistics, which enable us to filter the data and get, I call it just in time, meaning only the data we need at the moment we need it. And this is the smart metadata access. Meaning, for your question, if we were doing full scan, we would always need to go down to the disk and bring all the data again. However, we are not doing that. And this is, the ingest time allows us to do that. Let's take example for this combination of the Power 9, the NVLink, and the NVIDIA GPUs, and why it enables SQream to perform in such a manner. So think about splitting the data versus gathering the data. It's also connected to the question you asked. The internal architecture of SQream allows us to gather the data rather than split it. If you think about splitting the data and passing through the PCI or the NVLink, in our case, chunk by chunk, this is splitting the data. If you think about moving a lot of chunks in parallel, gathering them all into the GPU, and only then performing the operation, this is what allows us to do the group by and join on the large data set. This is why we are not bounded to the RAM. So we are getting the most out of the GRAM since we are collecting the data. We are loading it until we get into the maximum of the GRAM. We are gathering all the information needed based on all the optimization we've done on the chunks. And of course, in respect to the distribution of the data and all the metadata we collected. And now we can control the movement of these chunks on the NVLink. So basically, this is what allows us, and this is why we did the partnership both with Power9 and NVIDIA.
So I think one of the other things that we're doing here is we're optimizing between operations that need to be done on the CPU and on the GPU. So we have an automatic mechanism as well that decides whether or not a particular operation should be done on the CPU or on the GPU. As we know, not everything should be done on the GPU because it's heavily geared towards parallel processing, and some of the operations that we want to do will actually work better on the CPU. So that's built in as well. And all of the, as I mentioned before, all of the traditional, call them safeties of database and data warehouse that we've learned over the years, this is something that we've got built into the product. We have a couple of minutes left, so I'd like to give you a couple of examples of customers that we've worked with. Now, these case studies are not on the Power9. Okay, they're not on the Power9 simply because we announced the availability of the Power9 yesterday. Okay, but as Ayelet showed you, the testing that we've done, the ingest is much quicker, and the time to query is much quicker using the Power9 based on the testing that we did with x86 with similar GPU configuration. So this is a company actually in Thailand, one of the largest cell operators in Thailand. Okay, so they were running Greenplum. They had 40 nodes, 5 full racks. They had ingest time of 200 seconds that we brought down to 18 seconds. They had reporting time of, 6 hours it looks like. We brought that down to 46 seconds. They had ownership cost of over $10 million, and we were able to bring that down to $500,000. So this is an actual up and running use case. We don't like giving stories, so we basically get permission from our customers, and this was one of them. Another customer actually in the West Coast in the United States, one of the largest ad techs. So this is a very interesting one because it's something that we're running into a lot. So you can see that we're doing 85 terabytes a day of data. And what they were looking to do was to be able to construct their histograms better so that they can get more ad revenue coming out. You can see here that they have Hadoop as the primary, well, it's become their main data lake. They were taking out data from there into HBase Phoenix, and the queries were taking 5 hours. So we replaced that with 2 NVIDIA Tesla GPUs. We replaced their current installation. We did the data ingest into SQream, and they were able to reduce the query time to 5 minutes. Now, this is a great example of Hadoop because we're working more and more with companies that they started out with very small installations of Hadoop, and as this exponentially growing data has come into the organization, the amount of nodes that they have to support of Hadoop has grown to the point that one of the companies we're dealing with right now has about 250 nodes of Hadoop, and they're really drowning and they're struggling how to support that. And from what I was talking to a couple of the IBMers here, they told me that it's very similar in enterprises here in Europe, that there's a similar situation. So this was 86 terabytes a day. Now, they wanted to expand the amount of data that they were querying, that they were analyzing, because that would help them to build better histograms. So they actually went up to 360 terabytes a day that they're now ingesting. And the only difference is that we increased the amount of NVIDIA Teslas from 2 to 8. But they're still getting the same 5-minute response time. And this is something that wasn't even feasible previously. With the system that they had in place. So there's no question, we call it the trinity of Power9 together with the NVIDIA GPUs together with SQream, that we're able to really tackle these challenges of extreme amounts of data, extreme amounts of growing data, and the amount of time it takes to query that data. So I welcome you all to to speak to us after the session. Just to finish this, and I'll take questions. So just from who we are point of view, we were founded back in 2010. We've gone through actually a few years of R&D to get this product to the point where it is today, that you can see that, the results being given. The companies that we showed here are making significant business decisions and changes to how they're doing business based on the data and the additional data that they can have. So it's really driving business change, and which is, obviously an important part of what we're doing. So we've got 60 plus employees. We've got 10 patents. We signed a very strategic partnership with Alibaba Cloud back in May, actually in February, and then again in May. In February, we announced that Alibaba will be actually selling SQream on their cloud in China. So it's a similar situation that you have between Amazon and Redshift, but they don't own us. But then they invested in us in May. So actually, they're one of our big investors as well. So we've got one of the fastest growing cloud providers as our, you could call it our backing. We have our headquarters in the number 7 World Trade Center in New York, and we just moved into a nice facility overlooking the Mediterranean in Tel Aviv. And anybody who comes is welcome to a 360-degree view of the country. And I think you've been, actually, and you can vouch for that. So we welcome to see you. Thank you very much.